right, in the next section, we are going to take a look at graphing the other four trig functions: secant, cosecant, tangent, and cotangent. We'll start with just secant and cosecant in this part one. The first 7 steps are actually exactly the same as sine and cosine. Secant and cosecant are very, very closely related to the point that we actually need to graph either sine or cosine first if we are graphing secant or cosecant. So these first 7 steps just outline exactly what we did to graph sine and cosine. Now, if we are graphing secant, we are going to graph the cosine curve, okay? And that is outlined right here, right in step 7. If we are graphing cosecant, we are first going to graph the sine curve, right? Then the 2 new parts, okay, are going to be to sketch vertical asymptotes wherever the sine or cosine curve crosses the midline. And then we're going to sketch parabola-like curves that touch the minimums and maximums of the sine-cosine curve and then stay within the vertical asymptotes. Okay, so let's go through a few examples here. In our first example, we have 2 times secant of 1/2 times x plus pi over 2 plus 1. So if I'm graphing secant, what I want to do first is graph cosine. So this is just going to be 2 times cosine of 1/2 times x plus pi over 2 plus 1. So to graph these, right, we said we want to label our x and y axes. So we can start with our starting and ending points. So I'm starting 1/2 times x plus pi over 2 equals 0. So x plus pi over 2 equals 0. So x will equal negative pi over 2. Then my ending point, I set that bx plus c equal to 2 pi. So 1/2 times x plus pi over 2 equals 2 pi. Multiply both sides by 2 to get rid of that 1/2. And subtract pi over 2. So this would be 8 pi over 2 minus 1 pi over 2 would be 7 pi over 2. So I'm going from negative pi over 2 to 7 pi over 2. I need to get my key points here. So halfway in between there, right, taking the average between negative pi over 2 and 7 pi over 2, if I add those together, I would have 6 pi over 2. Cut that in half would be 6 pi over 4, or 3 pi over 2. Then halfway in between here, negative pi over 2 and 3 pi over 2. Again, taking the average would just be pi over 2. And halfway in between here, taking the average would be 5 pi over 2. So those are my key points on the x-axis. Then for the y-axis, and if I'm going up 1 and then my amplitude is 2, my range would end up being negative 1 to 3. So let's get our axes in here. So if we're going negative 1 to 3, I'll put the x-axis there, and I know I'm shifted to the left a little bit, so I'm going to bring my y-axis over a little bit and then label our points. Now, I'm actually, instead of like we usually kind of label everything maybe as if we would go up, 1, 2, 3, I'm going to stick to labeling each one as 1 here because I want to focus on the secant curve, which is going to be above and below the cosine curve. Okay? So then labeling my x-axis, here we can say negative pi over 2 to pi over 2 to 3 pi over 2 to 5 pi over 2 to 7 pi over 2. Okay, and I should also put in our midline just so we can clearly see where that is, and that would end up being at 1, right? So I'm going to put in a dashed line here at 1. So now let's sketch our cosine curve. So we know that cosine, I'll do this in different color, cosine starts at the maximum, goes to the midline, then to the minimum, then to the midline, back to the maximum. So here is, oops, that curve. Well, there we go. Okay, like that. My pen was struggling just a little bit there. Okay, but here's what my cosine curve would look like. So nothing different from what we've done so far. Now the new part, okay, is going to be to start by sketching vertical asymptotes wherever the sine or cosine curve crosses the midline. Okay, so I can see that that happens at pi over 2 and 5 pi over 2 in this case. I'm going to put in asymptotes. Okay, just use dashed lines to show your asymptotes. Okay, and then I'm going to sketch my secant curve. To do that, okay, I am looking at each individual spot. I'm starting at either a max or a min. So if I start over here on the left, I'm going to start at this maximum value, okay, and I'm going to sketch a parabola-like curve. Now, if we're only sketching one period, for cosine, we're only actually going to end up sketching this half of the parabola thing, even though we know it would continue on forever, and we'd have another asymptote, and the graph would continue on forever in both directions, just like sine or cosine. Then, for this part, okay, I would go to my minimum value and sketch. It kind of looks like a parabola. Okay, it's not, but it kind of looks like a parabola. Okay, and it is contained within the asymptotes here. So this green curve that I'm sketching is my secant curve. Okay, so this would really continue on forever in both directions. Okay, but the idea here is that it's so closely related to cosine. We want to just first sketch our cosine curve. And if you're just using a pencil, you would sketch that in lightly, right? I can use different colors here to emphasize the difference, okay? Now, I do want to show you what this graph would actually look like if it continued on, right? For our purposes, to sketch one period, we're just sketching our parabola-like curves, right? And we end up getting half of each of those here. But, okay, this would continue on forever, right? I have the cosine curve here in blue and the secant curve in red on this graph. Okay, we would just continue seeing this pattern forever. Okay, let's do another example. Let's do a cosecant. All right, so what we're really graphing here is sine to start, right? If it's cosecant, we're graphing sine. If it's secant, we're graphing cosine. So, same process, right? I start, I'm going to set whatever's on the inside. So in this case, that's pi times x minus 2 equal to 2 pi. So, or I'm sorry, equal to 0 for my starting value. Jumping ahead. So we'll get x minus 2 equals 0, add the 2 over, we'll get x equals 2. Then my ending value, we'll set that equal to 2 pi. So pi times x minus 2 equals 2 pi. Divide both sides by pi, we'll get x minus 2 equals 2. Add the 2 over, and we'll get x equals 4. So I'm going from 2 to 4 on the x-axis. That's pretty easy to split up into fourths, right? The middle would just be 3. Then the middle here would be 2.5 or 5 halves. The middle here would be 3.5 or 7 halves. So let's sketch in some axes. And so I know that I'm shifted pretty far to the right here. And so I'm going to go ahead and put my y-axis way over here. And then in terms of a shift up or down, I'm going down 1. And then my amplitude is only 1/2. So I know that this entire sine curve is going to be below the x-axis. Okay, so let's put it, say, here. So now, to label first, let's label the y-axis. If I'm going down 1, that's where my midline will be. And then I'm going up and down just 1/2. So in this case, let's say that I'm going down 1. Let's put that all the way down here. Then up and down 1/2. So we'll say -1/2 and -3/2. I'll sketch in my midline here. And let's label our x-axis. So I'm shifting 2 to the right. So we need to be careful here with making sure that our scale is accurate. So if I'm going 2 spaces to the right, let's say that we're going 1, 2. So if I'm saying that every 4 spaces is 1, well, that means that 3 would end up being here, 4 would end up being here, and then halfway in between each of those would be my 5 halves and my 7 halves. So now if I'm graphing sine, I know that I'm going to start at the midline, go up to the maximum, back to the midline, down to the minimum, and then back up to the midline. So my one period of sine, try to get a little curve here. It's going to look like this. So now, if I'm graphing one period of sine, I'm actually going to show 3 asymptotes for my cosecant curve. I can see it crosses the midline here, here, and here. So let's sketch in those asymptotes. And now the final step is just to sketch in parabola-like curves, okay, staying within my asymptotes, okay, and just touching my curve. Okay, so here, I'm going to have my one period of cosecant is just going to look like this. My green function here. Okay, and obviously we just talked about this would continue on forever in both directions, but if we're just sketching one period, this is what it would look like. Okay, now I did actually forget to answer part of the question on the first example, so let's go back to that and then we'll come back and answer that part here. It asks for the range and the period of my function. Okay, so period is exactly the same as when we did sine and cosine. So my period would be 2 pi divided by the b value. So 2 pi divided by 1/2 would be 4 pi. And again, we can see that is the value, or that is the range from negative pi over 2 to 7 pi over 2. That's the distance here. Now, the range, okay, the range is actually the exact opposite of my cosine graph. So the range of the green graph is going to be everything but this space between -1 and 3, okay? So my range would actually be negative infinity up to -1, okay? I am going to include -1, okay, because this point right here touches at -1. And then I'm going to say union, and then 3 up to infinity. Okay, now similar for this one. Okay, if I want to give the period, that is just 2 pi divided by the b value. So 2 pi divided by pi would just be 2. And then my range is everything except the range for my sine curve. So that's going to be negative infinity all the way up to -3 over 2. And -1/2 all the way up to infinity. Okay, so this um, is so similar to graphing sine and cosine that I am just going to show you these two examples. Okay? There are a couple more on the back that do include things like reflections, okay, and factoring out a b value. Okay, remember, if the b value is not already factored out for us, we need to make sure to do that. So I am not going to go through those examples in this video. If you want extra practice and you would like me to show you those, I would be more than happy to. Okay? But since these are so similar to what we've been doing, okay, I'm just going to do those first two examples. So that is it for this video. The final question is going to pop up asking you what questions you have.